Alright, CNT120, Chapter 1 Lab. We're just finishing up the Layer 3 section. My video cut off there, and I need to literally reload my packet tracer. Good thing I saved my progress. So before I leave Layer 3, I do want to make sure I have the two results I need. I need the IP config for my Harrisburg laptop. So I'm going to go back to my Harrisburg laptop here, open the command prompt, and I'll just do a brand new IP config here. And my number might be different from before because I restarted Packet Tracer. That is not a huge deal. And the same thing in your network too. If your number is like 52 or 53, that's okay. These are dynamic addresses being handed out, so they might very well be different than mine, and that's a-okay. So I'm going to copy that IP config result. I'll put a note in my text file here that this is the Harrisburg laptop IP config. I'll put that in there. I'll save that. And the other thing I need is we had done a ping at the end here. We ping Harrisburg, Harrisburg PC to Philly PC. So I need that result as well. So I'll go back to my Harrisburg PC. I'll open my command prompt, and I'm going to ping the Philadelphia PC over here. So let me double check its IP. It's 30.100, which I think was the same number we had before. So I'll ping 192.168.30.100. And again, if yours are different, it's okay. And I'm going to try to get a successful ping here over to the Philadelphia PC. And since I'm redoing this, I might have a timeout or two, so I'll just reissue that. I'm using the up arrow to bring that command back. And there's my successful ping. I will copy that, right-click copy, and then I will paste that into my text file here. And I'll put a note that this is the Harrisburg PC to Philly PC ping. There we go. Now I should have everything from Layer 3 that we needed. I'm going to minimize my notepad file. I'm going to close my command prompt there. And I will do a quick save on my packet tracer file. That saves your bacon sometimes. And I'll move on to Layer 4. Alright, so Layer 4. Layer 1, we looked at our cabling. Layer 2, we looked at our NIC. Layer 3, we looked at IP, our IP settings, and so forth. Now Layer 4. Layer 4 is concerned with getting the data from A to B. And two main protocols we encounter here are TCP and UDP. TCP gets used when we need a reliable connection. I need to make sure the whole email gets there, the whole web page gets there. TCP gets used. UDP is going to get used when we just need the data there quickly, like voice or video. TCP, and we're going to talk about these more in Chapter 4, but TCP is going to number everything, label everything, and make sure everything gets to the destination. So for Layer 4, we are going to look at the data that gets moved around when we load a web page, and we're going to look for this TCP information. And that is our indication of Layer 4 in our network. So to do that, we are going to, on the Philadelphia side, over here there is a packet sniffer. Packet sniffer is a protocol analyzer. It's going to make a copy of any data moving by that we can open it up and look at it. In real life, this would be something like Wireshark. Wireshark is a very powerful admin utility that you can install on a system, and any data moving by, it literally makes a copy that you can look at it. Very powerful for IT people. Now, it is a freely downloadable program that you can install on your own PC and run on your own network at home. But caution, caution, caution. Don't download this on a work computer. Don't run this on a work network. It's going to look like you're trying to be sneaky or compromise the network in some way. So leave it on your home system and your home network, and it'll be fine. Alright, we are going to move the laptop into the hub over here so that any traffic moving from the laptop into the network, the hub is going to make a copy and send to the sniffer. So to do that, we have to be a little sneaky, and I know the directions here aren't identical to what I'm going to do, but I'm going to go to the physical tab. I'm going to go to the Philadelphia side, the hallway in here, and this cable from this laptop, I am going to use the little delete key up here, and I'm going to delete that connection. Now the laptop is no longer connected to the network. I'm going to back out, and I'll go to the logical tab, and you'll notice the laptop's not connected. So I'm going to make a brand new connection on the logical side here, and I'm going to go from the laptop into the hub, and it doesn't matter what port. So now as this traffic is moving through this hub and into the network and back, the sniffer is going to get a copy of everything so we can look at it all. Woo! Okay, so now that that's in there, I'm going to look at the packet sniffer and look at what it's set up for. And it should be set up to be looking at DNS, HTTP, ICMP, and TCP. So I'm going to click on sniffer. I'm going to go to the GUI tab. And down here at the bottom, I should see DNS, HTTP, ICMP, and TCP, which is excellent. If by chance this is not, you can edit filters and make sure those boxes are checked were the ones that are indicated. And then that'll capture and just show those, not all the other stuff. Okay. We'll leave that there so we can see it. We're going to open the Philadelphia laptop, and we're going to open a web browser and open the web pages in our network. Now, we're not connected to the real network, so to speak. It's only the simulated network here. So I can't actually open like hack.edu, but there is a web server that has a little mini web page on, and it's at the CNT120 website. So I'm going to, so I'm going to leave the sniffer handy. I'll put it over there. And I'm going to open up my Philadelphia laptop. I'm going to make sure, I'm going to do ipconfig here and make sure this has picked up an IP, which it is. Good. I will go back to the desktop and I'm going to open the browser. And like it says here, you can do it, little browser. Once that loads, there we go. We are going to load the www.cnt.org. Now I'm going to try, let me see if I can get all these windows showing at one time. There we go. There's my sniffer window and my laptop at the same time. We're going to do www.cnt.org. And that's going to open the web page on this little web server. When you saw this load, over here on the left, we saw some protocols show up in the sniffer. That's what we want. We want to look at that stuff. And I get a little web page here that says, welcome to the CNT120 Lab 1 server. OSI models start to come alive when you look for them working in networks. And we see onions have layers 2 Shrek. Okay, so now in the packet sniffer, we should see some protocols like DNS, TCP, and HTTP. We're going to highlight this first, and actually real quickly, DNS. DNS is Domain Name Service. This is here that when I put the name in CNT.org, DNS resolved that into an IP address. And then we communicated with the server via IP address. That's what that does for that. Translates the name into IP. So that's why you see those first, and now we see TCP. So I'm going to highlight the first TCP packet, and I want to look at, let me slide this over a little bit, try to get it all fit here. We're going to look at the TCP message and try to look at the contents of this. So let's look at the TCP message. I'm going to make this a little bit larger. What I see first listed is the Ethernet header. It actually took the Ethernet header off the front of this data packet and printed all the information out. It then said, okay, after the TCP header, there's an IP header. It took this header off and printed all the information here for us to see. It then encountered the TCP header and put it, tore that off and printed all the information here. So this is what we're seeing for this communication session. Here's all these TCP header fields. There's a lot of fields here, and these all serve a purpose to make sure everything gets numbered, everything gets sent, everything gets delivered and put back together for this web page that we're about to load onto our machine. So if I look a little closer at the header fields, Ethernet, IP, TCP, let's look a little closer now. I will see in the Ethernet header, I see a destination MAC address and a source MAC address. Who sent it and who's receiving it. And these are MAC addresses that we looked at layer 2 on the network card. If I look at the IP header, I'll see a source IP and a destination IP. So this was a request coming from my machine going to the web server. 30.4 is the web server. So this request came from my computer going to the web server. I'm going to keep going on TCP. Source port is 1024. That's coming from my browser. When I see like large port numbers like that, they're dynamic. My browser assigns them dynamically, but in this case, it's most likely my browser doing that. And the destination is 80. That's the web server. Web traffic is port 80. HTTP is port 80. So this is coming from my browser, that little browser on my desktop there, going to the web server at port 80. Those are the source and destination port numbers. Now, your source port number might be 1026, 1027, 1028. That's okay. Those are dynamically assigned on the browser. The destination should hopefully be 80 because we're talking to the web server. That is standard. Anything web related would be port 80. All right. Before I go from here, before Mr. Brown gets too excited again, let's get those port numbers down in our text file. So here in my text file, I'll do a layer 4 results so I don't forget what this is, and I'll say TCP port numbers or something like that so I know what these are. And I need two of them. I need the source port and the destination port. So I'll put here source TCP port. I'll fill it in and I'll put destination TCP port, and I will fill that in as well. So in this one, my source was 1025. And again, if yours is 1026, 1027, that's okay. And my destination is port 80. Yes, because we're talking to a web server, it should be port 80. All of ours should be the same on that respect, since we're looking at that first TCP segment over there. So there's my layer 4 results. All right. Make sure you have that before we go any further. And before I go any further, I'll just take a quick peek over here again. Here is my Ethernet header layer 2, IP layer 3, TCP layer 4. So as my data is moving, remember we talked about data encapsulation, each layer it moves down through, a little header field gets added with the information it needs. So in this case, the TCP header, the server needs that, and my browser needs that to make sure these chunks of data get handled correctly. Going to a web server, coming back to my browser. IP header has the source and destination IP. That way routers can route this to the correct network. It routed it from my PC across that link between the routers and then over to the other network. And that was all done by reading these source and destination IP addresses. And then Ethernet, we have source and destination MAC. These get used so the switch can get it to my computer as opposed to, the laptop sitting next to me, if you will. So that, as I look at this chunk of data, that's what I'm seeing, all those header fields. So as we read about the end of chapter 1 there with all the data encapsulation, here is all of those header fields, all those headers being added on. All right, there is layer 4. I'm going to save my notepad file here, and I might want to save my packet tracer so I don't lose my progress. We'll come back in the next podcast for upper layers.